Hello students, in today's class we are going to learn about the EOT, the question 1 of the EOT. Okay, so guys, as per the question number 1, we need to focus here that what is our question and what exactly we need to study. Question 1 as per EOT, show that by a definition. Okay, we should know what should be the definition. The electric current. Okay, we should know what is electric current and what is the relation. So electric current is related to net charge through the equation between current and charge related to time. Okay, so just try to understand. First time he's talking about current and time relation. Second, he's talking about charge and time relation. Okay, fine. Apply the relation to calculate electric current at a point. Okay, that is something good. The I is equals to dq by dt, net amount of charge passing through a given point in time t. Okay guys, so there are few things what you need to focus. So I'm going to explain you here one by one. So first thing, he's talking about the definition of electric current. So we need to understand, let's say we have any wire. This is the wire. Okay, and in this wire we have electrons are moving, or you can say the charge is moving. Fine. So when the electrons are moving per unit time, that is called your current. So in simple terms, can I say I is equals to charge per unit time. Okay, but which formula is this one? This is the major thing you need to understand, because when we read the question, he's talking about the point and complete. These are the two major words. Okay, let's say you need to understand, if I'm talking about the full wire, point A, full wire, okay, complete, then I is equals to charge by time. Full current, you can understand, this is the complete current, this is the full charge, and you have complete time. Yes or no? And the complete current also. This is for full wire. If you have in the question second point, okay, where we need to use a term called differentiation. Why differentiation? This is the major question. Let's say this is the complete wire. Okay, and I'm breaking down this wire into a one part. Let's say this is the part where I need to find out. Okay, so if I'm looking for that particular part, then current I should be equals to dq over dt. Fine. And the C, which is the major point, if you need to find the charge at particular point. Now you have a current and you need to find out the charge. So in that case, can I say I is equals to dq over dt? Okay, now just take this dt this side. So can I say dq is equals to I dt? Fine. This is a small charge, but I need to find complete value for complete value of charge. So can we integrate both sides? Okay, so integrate dq, which is equals to integrate I dt with the limits. Let's say time 1 is your limit and time 2. So what we get, what should be the final formula? Q is equals to integration time 1 to time 2 I dt. Clear? So these are the basics. Okay, now we are going to discuss about the formula and the units. Okay, so if I'm talking about the formula, So we are going to use basics, four formulas. First, for the charge, can I say Q is equals to NE, where N is the number of electrons and E is your charge, that is 1.6 times 10 raised to power negative 19. Fine. Okay. Second, I is equals to Q divided by T. You can remember this formula with the help of this triangle. Okay. You can place Q here, I, T. Fine. Okay. So in this, we have two more. So if we are looking for Q, so I can say Q is equals to integration I dt time 1 to time 2. That is case of integration. And if you are looking for the current, I is equals to dq over dt. Fine, guys? Okay. Now, after formulas, we have the second term that is called units. Okay. Now the unit parts, units. So first we have word I, which is equals to current. And the unit is, yes, tell me, ampere. Good. Second thing, we have Q, which is equals to charge. So can I say the unit is coulomb. Third is T, time. Time you already know, that is the second. T for time, and the unit is second. So can I say ampere is equals to coulomb per second. Clear, guys? And the second, the major point, I will write major. So can I say coulomb or coulomb is equals to ampere second? Yes or no? Okay, this is the major thing. So guys, till now what we have learned, we learned about the current, what exactly the current is. Second, for the full wire, if we are looking for the full wire, it should be Q divided by T. If we are looking about the point, why point? Just check what they are asking us, point, okay, dq over dt. Fine, guys? Okay. Now, before moving forward to the questions, I just want to explain one more thing to you that will help you, okay, while solving the questions. Okay, next part. See, if we have two parts, one is differentiation, one is integration. So how to solve these things, I will tell you some basic things so that you can solve them easily. One is differentiation, one is integration. Differentiation and integration. So in terms of differentiation, we have a simple formula, y is equals to x raised to power n. Similarly here also, y is equals to x raised to power n. What is the meaning of differentiation? Differentiation means to break down. Let's say if you have a wall and you are breaking down this wall in terms of bricks. Let's say this is your brick 1, brick 2, brick 3, brick 4. Like this, you are breaking them down. This is called differentiation. But in opposite, integration means you need to add them. Remember, to add. And here, to break. Clear? Okay. Now we have a simple value, simple equation, solve it. So if I'm differentiating y, dy by dx, which is equals to power shift n, x raised to power n minus 1. See, we are reducing the power. Fine. Okay, just take an example. Let's say y is equals to x raised to power 3. Fine. Okay, solve. Dy divided by dx, which is equals to x raised to power 3 plus 1. Sorry, not this one. 3 minus 1 and power 3 is shifted. So what is your answer? 3x square. So means you are reducing the power. Reducing power. Clear? Okay, this is your first step, first part. Okay, similarly here what will happen? I told you add, it means addition of the power, addition of power. So integration x raised to power n dx. So what is the formula? X raised to power n plus 1 divided by n plus 1. Okay, first we'll solve a numerical and we solve a question. Let's say we have a question x power 3 dx. Solve this. X raised to power 3 plus 1 divided by 3 plus 1. So can I say what is our answer? X raised to power 4 divided by 4. Till here clear? Now you can solve the questions. Okay. Second thing, if you have any constant value, you need to focus, this is something important. Let's say y is equals to 5. Is there any x value? No. Can I say x raised to power 0? Okay, I'll explain this part again. Sometimes students get confused. So let's say, can I say 5 is equals to 5 multiply 1? Yes or no? Okay. And any value, let's say x raised to power 0. Can I say this is equals to 1? So 5 is written as 5 multiply 1, which is equals to 5x raised to power 0. Yes or no? Clear, guys? Okay, now solve this numerical. So y is equals to 5, make a differentiation, dy divided by dx equals, can I say d by dx of bracket 5x raised to power 0. So take out 5 outside. So derivative of x raised to power 0. 5. So 0 will come out. I told you power shift 0, x raised to power 0 minus 1. If you multiply anything with 0, 5 multiply 0, x raised to power negative 1, it will become 0. So what do you understand? Derivative of a constant value. Derivative of a constant value is 0. Now let's see what will happen with the integration. Okay, now let's say second case, integration of a constant value. Let's say 5 dx. So I told you the same thing. Can I write 5 equals to 5x raised to power 0 dx? Yes or no? Okay, now solve this. Take out 5 outside. And what is the equation? X raised to power 0 plus 1. See, you can check from here. 0 plus 1 divided by 0 plus 1. Fine. So what is the value? 5 x raised to power 1 divided by 1. So what is the answer? 5x. Clear, guys? So why I teach you? See, if you already know that differentiation and integration, that is perfect for you. But if you don't know, these things will help you to solve the questions. Fine, guys? Okay. So till now we learn about the current, what exactly the current is. So current is I is equals to Q divided by T. That is for the whole wire or for the whole system. Okay. Then we learn about the point. Point means at particular point, if we are looking for, then it is in terms of dq by dt. dq by dt, or if we are looking for charge, that is the integration I dt. Time 1 to time 2. Fine. Okay. After that, we learn about the differentiation and the integration. Okay, guys. Now jump to the question. So now we have question number 1. And you need to focus more in this question. And after that, we will do the practice questions. Okay. Before that, few things on which you need to focus more. Okay. The first thing. See, when you are going to solve the numericals, they will give you lots of notations and you need to use in terms of units also. So what is that? The first thing is this small m. So what is this small m? Small m means milli. What is the meaning of milli? 10 power negative 3. You need to remember this thing. So that is your first. So if we say milliampere, so can I say 10 power negative 3 ampere? Fine, guys. This is your part 1. Second part, micro. This is called micro. So micro means 10 raised to power negative 6. So if anyone gives you microampere, so can I simply say 10 raised to power negative 6 ampere? Fine. Sometimes they can give you other values also. Third, let's say small n, nano. Nano means 10 raised to power negative 9. Similarly, you can solve the other things. Fine. Okay. Now, in terms of time, you know 1 minute is equals 60 second. Okay. 1 hour is equals to 60 minutes. Can I say 60 times 60 second, which is equals to 3600 second. Fine. Now the last, which is the most important point. What is MAH? MAH. Okay, first thing is milli. So what does it mean? 10 power negative 3. Clear? Second is ampere. Ampere remains ampere, no change. And third thing is R. So can I say 3600 seconds? Yes or no? So combine all these three. So can I say 10 raised to power negative 3 multiply 3600 ampere? Sure. Ampere, and there is a word called second. There is a word called second. Yes or no? Ampere second. So can I say if I multiply these two, so 3.6 coulomb. This is very important. Guys, still here clear? All the points are clear? Okay. Now we will jump to the question number 1. Okay, so before going to start this question, for my all the YouTube channel students, I just want to tell you guys, if you want to know about all these questions and if you want to take the advantage of all the questions, so you can join my paid group, and in which I explain all these questions. You just check the way I'm explaining. So if you want to learn all these things, the main problem and the practice questions, you can just see. So for this question, there are few practice questions and which will help you for your final exam, during your final exam, and you can easily crack your final exam. So if you want, you can just you can see in the video I already give you my channel link, and there is one more link for if you want to join my premium classes. So you can add your name and all other informations, and there is a small fee, and you can just be the part of my premium group. Okay guys.